Hi all. So the last class we have been discussing about the concepts of algorithms, okay, the need, the issues, the importance. Then we have seen the different approaches of algorithm, okay. Then we have seen what are the different categories of algorithms which are coming like sorting, insertion, delete, and all those things. Okay, then we have seen how we are doing the analysis of algorithm, okay, and give me a second. Yeah, analysis of algorithm, which included two things, that is priori and posterior. So priori means like before doing the implementation of algorithm using any programming language. And then we have seen the posterior. Posterior is nothing but the after the implementation, we are going to analyze the algorithm. Now, when I say I analyze the algorithm, why you are analyzing the algorithm? Because in order to find the complexity of algorithm, how complex a algorithm is. And now we have seen that how the difference happens in terms of cost, in terms of hardware difference when we have the algorithm analysis. Okay. Now next, what we have is the algorithm complexity. So now when I actually build an algorithm as a particular solution for a problem, I always check how much complex it is, okay, how much time it may take in order to run a code, and also how much space does it take in order to run the code, like space in the sense memory space. So the depending upon that, the complexity of algorithm is divided into two. One is time complexity and another one is space complexity. Okay. Now let's see one by one what is time complexity and what is space complexity. So to analyze the performance of a algorithm, we are measuring the performance of the algorithm using the two factors. One is time complexity and another one is space complexity. Okay. Next thing is the time complexity. So the time complexity of an algorithm is the amount of time required to complete the execution. So whatever code we are having, right? So those entire code, the total time taken or total time required to complete the execution of the algorithm whatever we have built, that is nothing but the time complexity. So the time complexity of an algorithm is denoted by the big O notation. Okay. Yeah, so that notation, everything will be learning detailedly how to find the notation, how to actually find for a particular algorithm what is the complexity in terms of time and space, how we are going to measure it, and also how we are going to write it. Okay, if I measure a distance, I will be writing it in terms of what units in meters, correct? So I'll be knowing how much long it is, if it is coming in the centimeters or like that. In the same way, we'll be using different notations. So this different notations will tell us what is the case of the complexity, time complexity for a particular code. So all those things we'll be learning these days. So whenever I say algorithm or analysis of algorithm, okay. Uh, so yeah, analysis of algorithm, always one thing come to our mind, that is nothing but big O notation. So here big O notation is the asymptotic notation to represent the time complexity. Shall be the next concept once we learn this algorithm would be asymptotic notation. So that will be learning further. So the big O notation is nothing but that asymptotic notation in which we are representing the time complexity. After that, the time complexity is mainly calculated by counting the number of steps to finish the execution. Okay, and it's not as simple as that. We say like we are calculating just the number of steps to finish the execution. Means if I build algorithm, there are many steps, right? So step by step procedure it is, whatever we call it as the algorithm. So in order to step by step procedure it is. Okay. Now, in order to complete that entire steps, okay, in order to finish the execution for that steps, how much time will it take? So that is nothing but the time complexity. Now, let's consider one example. Okay, let's understand the time complexity through an example. So we have sum is equal to 0. Then suppose we have to calculate the sum of n numbers. Okay, sum of n numbers means if I say first n numbers I have to calculate. 10 numbers if I say 1 to 10 I have to calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus like that up to 10 I want to calculate. So this code over here is yeah, okay. So now for I equal to 1 to n, okay. Now this is nothing but any code. This is just a pseudo code. Okay, it's not in a form of code. This is what we call it as pseudo code. So it's not we are entirely implementing the pseudo code in any language. Okay, we're just writing it so that we can understand it. So we are initializing the variable sum is equal to 0, and then for I equal to 1 to n, and sum is equal to sum plus I. Okay. For I equal to 1 to n. Okay, so that is what I told us from uh, 1 to from 1 to n you are adding. Okay, means sum of first n numbers. So sum is equal to sum plus I. For each and every new i's you are getting, you are going on added. So when the loop ends, the sum holds the sum of the n number. The original variable of sum will be holding the sum of all those first how many numbers you trying to get. So its sum will be stored in that sum variable, and then we will be returning the sum. So in the above code, the time complexity of the loop statement will be at least n. Okay. So now here, what we are considering it as time complexity means the amount of time taken to execute that code. So what will be the more time complexity? Okay, which will be at least n. Okay. So if the value of n increases, then the time complexity also increases. Means the n is nothing but the number of inputs you are having. So if I want to find the sum of 10 numbers, so if it takes some unit time to execute or to add one number, then up till 10 number, how many time it will take? Into 10, correct? So if I have 50 numbers, means it is depending upon what is the number of n I have. So whenever the value of n increases, the time complexity also increases. So the while the complexity of the code, that is return sum, will be constant as its value is not dependent on the value of n. Okay, so when I say about the time complexity, we'll be considering how much time will be taken to the each module of your code, each section of your code. Okay, so now we have two sections here. One is this for loop. Okay, means it will be iterating through how much ever inputs you are having. So depending upon that inputs, you are going to go on adding it. Okay, and we have one more operation which is returning the sum, correct? So returning the sum means it is one operation, one single operation there. Whatever the number of inputs you are having, we just don't care about it. So that is told here. Okay, so return sum will be constant. Okay, because it's not going to change depending upon your increase in number of the inputs. So its value will not depend on the value of n and will provide the result in one step only. So we generally consider the worst time complexity as it is the maximum time taken for any given input size. So let me explain to you. Now I have told this code has two pieces of code, okay, in which I have to consider how much time the each piece of code is taking to execute. So if I consider this one, that is for I equal to 1 to n to this one, this is one module I can consider, and this is another one. So how much time this will take? This is depending upon the input. If your input increases, the time taken for this particular code to execute will also increase. Now, what about this one? Okay, return sum. What about this one? So sum is nothing but it will be after adding how much ever number or input we are having. So depending upon that, whatever sum we are getting, whatever what final a total you are getting, that would be returned. Okay, so that is the constant. It would take only minimum amount of time. So now I have to consider both the times, correct? So the time for the first operation plus time for the second operation, correct? Time for the first operation and time for the second operation. So I have to add it, correct? Now, when in time complexity, what we always consider is the worst case time complexity. Okay, worst case time complexity means which will take the higher time to execute. So if suppose if this takes lower amount of time, so if I say this entire code takes this much amount of time, if I consider the best case, or if I consider this chunk of code who is taking only little bit of time, if I say that it this entire code takes that much amount of time, it is not true, right? If suppose I'll give you an example, if this code takes 10 seconds of time to execute, and if this takes 15 seconds of time to execute, okay, now total time will be how much? 15 plus 30 seconds, correct? But yeah, 15 plus 15 plus 10, that is nothing but 25 seconds. Okay, now we will leave the total time, okay, but we will consider which will take the highest amount of time to actually execute your algorithm, and that time, that piece of code complexity we are going to display always for any algorithm, whichever is having whatever amount of steps, we will be always considering which chunk of code in a given set of algorithm, or in the given steps of in a particular algorithm, is taking higher amount of time to execute or to complete its execution. So that is considered as a worst time complexity. Okay, so because it is the maximum time taken for any given input size. Yeah, okay. So that is about the simple way in which how we are going to analyze the algorithm. So for that, we need to learn some extra things also. We will see that one by one, which will be coming in the asymptotic analysis part. Next thing is space complexity. Okay, so time complexity we have already seen. Now next thing is space complexity. And algorithms space complexity is the amount of space required to solve a problem and produce an output. Okay, so time complexity means the amount of time taken to solve a problem and produce the output. But what is the space complexity? The amount of time taken, sorry, not time, here it is space. The amount of time, space taken in the memory to solve a problem and produce an output. So similar to the time complexity, the space complexity is also expressed. That is nothing but in big O notation. We are having it. Okay. So similar to the time complexity, space complexity is also expressed in big O notation. So now if I say big O notation is giving you what type of time complexity? Worst case. So here it also will consider for the space also will be considering the worst case complexity. Now, for an algorithm, the space is required for the following purposes. Now, we'll see why and all we need a space inside the memory. So, depending upon that, I can make sure, okay, if I write this particular code, which is belonging to this, any of these four purposes, it will take the memory in the space. Treat this kind of code or this chunk of code, how much time or how much space it will take. Okay, so altogether, how much it will take, and we will be considering the maximum space taken by a piece of code, and that we'll be considering as its space complexity for that entire algorithm. Now we'll see which are those purposes where the space are being used. So to store program instructions, okay, one thing is to store the program instructions. Second one is to store the constant values. Okay, like for example, pi. Okay, what is its value? 0.14, and whoever comes, whatever happens, we are not going to change the value of pi, correct? From very small itself, we are using it as pi value is 3.14 while finding the what while finding the not radius, area or circumference of the circle, we are being using that. So now next one is to store the variable values. Okay, constant values, variable values. Even if while performing, I may want to store some temporary values. Okay, so there are much more things in which actually the space is required. Okay, when we are executing a code. And one more thing is to track the function calls, jumping statement, etc. All those things, and no, we need some space in the memory. Okay. Now there is one more space which is called as auxiliary space. So the extra space required by the algorithm Excluding the input size is known as the auxiliary space. Okay, as I've told you, if I create a temporary variable in which I'll be storing the value only in order to perform some operation and in order to get some output. So that is the extra space, correct? So this extra space which is required by the algorithm, excluding the input size. Like in order to store a input variable, input data, the variable you're creating would be a different, okay, which is nothing but to store variable values, all those and all. But extra space is different when you're actually performing the operation for us for a particular problem, okay, and that is present in your algorithm. And that extra space required by the algorithm, extra space taken by the algorithm, what excluding the input we will be considering it as auxiliary space. So now the question is, we have seen whenever the space is used in whatever purposes or in whatever cases we are using the space. So we are using those spaces, correct? Okay. Now, should we also consider that auxiliary space, whichever is considered as the extra space which we need while executing a set of code or performing an operation? Do we need to consider those extra space also at the time of calculating the space complexity? So the question answer is yes. Okay. So the space complexity considers both the spaces, that is auxiliary space and the space used by the input. So that's how this equation we are getting. In order to calculate the space complexity, we will be having auxiliary space plus input space, input size. Okay. Now, we have seen different sorts of algorithm, right? So now just to see the types of algorithm, like search algorithm and sort algorithm. So what are they and how it is working? So on now, why we need search algorithm? Okay. So on each day we search for something in our day-to-day life, correct? And similarly with the case of computer, huge data is stored in a computer, that whenever the user asks for any data, then the computer searches for the data in the memory and provides that data to user, correct? So now everything has been easier for having the search option. So for the search option to work properly, because everything we are storing it in the computer memory and computer have to search from the memory and those things, correct? Now for whom we are writing the algorithm in order to solve these problems which is coming in these type of places, correct? So that is the use of the search algorithm. Okay. So there are mainly two techniques available to search the data in the array. Okay. If I have an array which is storing some values, okay, and the two techniques of search algorithms are nothing but binary search and linear search. Okay. Yeah. So let's see just a brief, okay, what do you mean by linear search? So whenever someone asks, okay, you have learned about algorithms, so tell me about the algorithms and what are the different algorithms we have in DS. Okay, so many different algorithms will be there in many different branches of computer science. Okay, like for example, if I take AI, artificial intelligence, there are many different algorithms there. Okay, like for example, genetic algorithm and ID3 algorithm. Okay, so in different places we'll be having different algorithms. Okay, now if someone asks, okay, you are learning DS and what are the different algorithms you're having? So we can say we have search algorithm, sort algorithm. In search algorithm, we have binary search and linear search. In sort algorithm, we are having bubble sort, quick sort, merge sort. Okay, so it goes on like that. So each and everything as an operation, how we are doing, how to write the code in order to implement it in terms of the machine level, everything will be learning further. Okay, so now as a part we are learning the brief, okay, like introduction for the data structures and as well as the algorithm and as well as the complexity analysis. So what this linear search is doing is a very simple algorithm that starts searching for an element or a value from the beginning of the array until the required element is uh, found. Okay, it should be found. So linear search is a very simple algorithm that starts searching for an element or a value from the beginning of the array until the required element is found. Okay. So this is how it should be. And it compares the element to be searched with all the elements in array. So now how it is working, if I have an array of 10 elements and I want to search for the sixth element, okay. Now I don't know that it is present in the sixth element and I have to search for it. So how we can search, okay, internally, what logic we have to think of is, we have a number, we will provide the number, we are searching for this number. So what it will do is, it will go and visit to each and every element and check whether it is matching with your element. So if the match is found, then it returns the index of the element, okay. Otherwise it will return -1. So index of array, it will start always from 0 to 1, right? We know that, okay. So it will start from 0 to whatever the number of elements you are having in the array, to that, and -1, okay. The index goes on like that. So if the match is found, to access the array element, we need the index, correct? So it will be returning the index. So by thinking all those things, and we plan the logic, and we build the algorithm, and we implement it using any programming language. Now, this algorithm can be implemented on the unsorted list. Okay, so now here, for the linear search, no, we are going on in a straight line by searching for all the data. Okay, so this can be done in the unsorted list. Whatever your array elements need not to be sorted in ascending or descending order. So whenever I found the element, I'll be just returning the index of that element. But then there is one more search, which is binary search. How it is working? For this search, for the binary search to work, no, the logic of binary search is in such a way that the elements needs to be in a sorted order. Okay, so a binary algorithm is the simplest algorithm that searches the element very quickly. Okay, instead of linear search, binary search is very quickly rather than linear search. So how it is very quick? Because it is used to search the element from the sorted list. Okay. And the elements must be stored in the sequential order or the sorted manner to implement the binary algorithm. So as the name suggests, why the binary is, for example, if I have sorted list, no, I will be knowing, if I know the middle term, I'll be knowing that if I check whether the data, whatever I want to search, is less than or greater than the middle number. So if my number which I want to search is greater than the middle number, then should I search for it in the right hand side of my number if their numbers are in sorted order? Because everything whichever comes to the left side of the middle number would be less than that number itself, correct? So I don't have to search for that half of element itself. That is why we call it as binary search. Okay, each time you will be checking for a middle number, and then you will be then you will be checking whether this number, whatever I want to search, is belonging to my left side or right side of middle number. So if it is coming to the left side, then you go only check in the left side of that number. So that left side of the number, again you find the middle value of that left side numbers, and you find whether the number you want to search is greater than or less than that middle element. Okay, so in this way, it makes our time very much easier. Okay, I mean, the time taken to identify or to search the element in the sorted list would be very easier in if you are using binary search instead of linear search. Okay. So some tools, if they use, even if they have sorted list, if they have linear, correct? Okay, so that matters on how you're using and in what type of data you're using. So if some data are not being able to sort, then there is no issue, then there is no problem. You have to go with the linear search only. Okay. Yeah. So binary search cannot be implemented if the elements are stored in a random manner. Okay, if you implement binary search, if the elements are not in a not in a sorted order, what happens? You won't be getting the proper. You will never get the element what you are finding. Okay, it may get if you have that great luck, but sometimes, most of the times, you may not get it, and the computer will fed up of the element. Each time you divide, you won't be getting any numbers. Okay, so everything will have logic to be built. Okay, so here also we'll be having some certain steps to undergo when you want to do the binary search. So that is why we include it in the types of algorithm. So In binary search, what we are doing, the mainly thing is, first one is it should be the sorted list, and next one is it is used to find the middle element of the list. Okay. So when you find the middle element of the list, you can actually make out whatever element you're searching for is present in the left side or right side of that middle element. Depending upon that, your time to search a number would be decreased rather than linear search. Next, we'll come towards the sorting algorithm. So what do we mean by sorting algorithm? So algorithm, now, since I have told you, the binary search will work good on sorted list. So we need some mechanism to sort our list. If your element is by default, the element in the array is not sorted. So sorting algorithms are used to rearrange the elements in an array or a given data structure, either in an ascending or descending order. So I can do that in the ascending order, or else I can do that in the descending order. Which one? The sortings. Okay, depending upon the use cases. So the comparison operator decides the new order of the elements. Okay, so we have the sorting algorithm, and there are many different sorting algorithm. Okay, as I told you, merge sort, quick sort, bubble sort, each and everything are working in their own way. Now we'll see why we need sorting algorithm. One, I have already told you, we need for the binary search to work, we need sorting algorithm. So if your element is not sorted, then we need someone to sort it. Correct. So an efficient sorting algorithm is required for optimizing the efficiency of other algorithms like a binary search algorithm. So as the binary search algorithm requires what? An array to be sorted in a particular order, mainly in ascending order. Okay. Most of the time, it will sort by default in ascending order, and it produces the information in a sorted order, which is a human readable format. And searching a particular element in a sorted list is faster than the unsorted list. Okay, this I have already explained. So this is all about the algorithm. So we learned a lot of things from the side of the algorithms. Correct. Now, okay, even after building the algorithm, we need to know whether the algorithm is efficient or not. Like we need to do the complexity analysis on the algorithms. Correct. So what we have to do is we need to learn the notations, or the how to calculate time and space complexity, and also how to notate it, so that whenever someone sees, I have written an algorithm, and this is a complexity. So what do you say about it? Do you want to change the algorithm? We'll just keep the algorithm. So if the developer want to ask to someone, and that someone also has to need to have that knowledge of what is complexity analysis, and in order to reject or accept that particular algorithm which is written by the rookie developer or junior developer. So we need to know that much piece of information on the what notations and analysis, what we call it as asymptotic analysis. Okay. So asymptotic analysis is nothing but we are doing the analysis on the algorithm just to know what is the complexity of time and space. Okay, what is the complexity of time and space? What happening there, and in that analysis, it will also come how to do the analysis on a particular return algorithm. Okay, some mathematical formulas all will come. Okay, functions will come. So in which you'll identify and will learn how actually we have to calculate the complexity, and something needs to be neglected and something needs to be considered, and what is the thing that needs to be considered also we'll be seeing. And apart from that, we will be also seeing the different notations which we use. Okay, as I've told you, there is something called as best case, average case, and worst case. So we always be looking for the worst case, right, in complexity analysis. So uh, for the different cases, we have different notations. So whenever someone looks, no, he has to understand. Okay, the complexity analysis of this algorithm is done based on the worst case. Okay, so I can consider, okay, so this algorithm may not require because it takes this much amount of time in worst case. So I can make that particular what analysis, okay, and I can say whether some improvement need to be done in a particular algorithm or not, like that. Okay, yeah. So that is about the asymptotic analysis. So more into it we'll learn in the next class. Okay, so that's all for today. Thank you.